Okay, let's get going on this second 9 weeks test review, day one, part one. The first question is dealing with quadratic inequalities. Given the graph of y equals 3x squared minus 7x plus 2, find all the solutions to 3x squared minus 7x plus 2 greater than 0. All right, first thing we're going to look at is um, this symbol right here. It tells us some information. Um, it tells us that it's going to be shaded above because it's greater than, and that it is going to have open circles because it's greater than. If it was equal to, it'd be closed circles. All right. So since the graph's already graphed for you, we don't really need to know whether it's opened up or down. It's already done for you. So all you have to do is put open circles where the x-intercepts are and shade above the x-axis. All right. Well, usually it's pretty straightforward on what the intercepts are. Like right here, it's 2. Right here, we don't really know. So we actually have to factor this. Um, and so I'm going to do another page. All right, 3x squared minus 7x plus 2. So 3x squared minus 7x plus 2. Okay, so this is where we do the wheel. All right, 2 times 3 is 6. That goes on the top. And the middle term, -7, goes on the bottom. All right. And down here on these two pieces, we can put 3x because it's whatever that coefficient is, that has to go down here. All right, so now we have to figure out what two numbers multiply to get 6, but add to get -7. So the two numbers will be -6 and -1. All right, so how do we read this? -6 over 3 on the left side can be reduced to -2 over x, like -2 over 1. Okay. The one on the right just stays the same as -1 over 3x. So what we could do is set these factors equal to 0 and solve, but the shortcut is, if you were to solve, just take the opposite of what that number is. So since it's -2, the opposite of that is +2, and since this one's -1/3, it's going to be +1/3. All right, so those are the two x-intercepts. We already knew 2, that was one of them. So if we go back to the chart, we already know that that's 2. All right, and then over here, that's going to be 1/3. All right, so when we write our final answer, and you got to pay attention to this portion right here. It says interval notation. A lot of people make the mistake of writing it in inequality notation. All right, so be careful about what they're asking for. So if I look at the graph, which part is shaded? So from on the left part of the graph, it's shaded from -infinity to 1/3. All right, since infinity, you can never reach that, so we got to use parentheses. And since it's an open circle at 1/3, we'll close it, or we'll use parentheses. Then we use the union symbol, and then it picks back up and starts at 2. Because it's an open circle, we're going to use parentheses. And then it works on its way over to infinity. So that would be your answer to this solution, to this problem. All right. Let's move on to number 2. All right, -10x squared plus 90 is greater than or equal to 0. So I'm going to start a new page. Negative 10x squared plus 90 is greater than or equal to 0. Okay, so this one, the last one we factored it by using the wheel. This one you could use the GCF. All right, so first I'm going to take out a negative 10 from both terms, and I'm going to be left with x squared, and since I took out a negative, this becomes a negative 9. All right, because a negative times a negative is positive. All right, so now I set my factors equal to 0. Negative 10 equals 0. That doesn't make any sense, so we don't do that. So now we've got negative, or x squared minus 9 equals 0. Well, you could factor that by breaking it up into two pieces. That's the difference of squares, so that can be factored into that. All right. Then we set each factor equal to 0 and solve. And you can kind of do this step in your head. Once you see that x minus 3 and x plus 3, you could kind of skip this step right here and just say, okay, I know it's going to equal positive 3 and negative 3. All right, so those are going to be your two x-intercepts. All right, so let's go back to the question. All right, and so now when you're graphing it, you always got to look at the leading coefficient. If it's positive, it's going to open up. But since this one's negative, it's going to open down. All right, so we know our two intercepts are negative 3 and 3. Also, this tells us right here that it's going to be shaded above and closed circles. All right, so at negative 3, closed circle, and at 3, closed circle. And because the leading coefficient is negative, it's going to open downward. We don't really care about how high the vertex is and all that stuff. We just need a rough sketch. All right. So then it said shade above. So the part of the graph that's above the x-axis is this part. All right, and that's including the closed circles. All right. So now, how do we write this answer in interval notation? So over here on the left side, there was two parts that were shaded, so we had two answers. Over here, we have one part that's shaded, so that's going to be one answer. So it goes from negative 3 to 3. Now, since it's closed circles, we're going to use brackets. All right, and that would be the solution to this problem right here. All right, so a couple things. You got to remember how to sketch the graph. Is it pointing up or down? The inequality symbols, they tell you two things: where to shade and what type of circles to use. When you're writing your interval notations, remember when to use parentheses, and when to use brackets. All right, let's move on to number 3. Okay. So number 3, again, it's already graphed for you. You can see the x-intercepts clearly, so we don't really need to factor it. All we need to know is that it's shaded above and closed circles. Okay, so I'm going to close these intersections, or intercepts, and then I'm going to shade above. All right, we got to read these directions carefully too, because it says solve each quadratic inequality graphically. Write your solution in inequality notation. So be careful when you're doing these. Read the question carefully. Now these answers are slightly different. All right, I mean they're They say the same thing, just written differently. All right, so this goes from -1 less than or equal to, because there's a solid circle, x less than or equal to 1. Okay, so, and if you were to write the inequality notation or interval notation, it would look like this. So the answers look very similar. All right, they should always go in the same order. Numbers on the left match, numbers on the right match. Brackets if it's equal to signs, and parentheses if it's not. So this is the answer I want in this situation. Okay. All right, so this next one, x squared minus 4x greater than -3. Before we begin this problem, we have to set it equal to 0. So x squared minus 4x greater than -3. So I'm going to add 3 to both sides. So I can get x squared minus 4x, actually that's a plus, greater than 0. Alright, so now it's in a form that I can factor. Alright, couple things before we begin. We know it's going to be greater than 0, so we're going to shade above. And because it's not equal to, it's going to be open circles. Okay. So I'm going to use the wheel over here. Again, the 3 times the, it's understood to be 1 here, that goes on the top. This number goes on the bottom. And down here, because it's a 1x squared, we'll put 1x and a 1x there. Alright, so now you ask yourself, what two numbers multiply to get 3, but add up to get -4? So again, we're going to do -3 and -1. Alright, so now what are our solutions? Or in this case, x-intercepts. So again, like I said before, instead of doing setting a x minus 3 equals 0, you could just go ahead and do that part in your head, or take it from the wheel, just do the opposite, and there it is. And the same thing over here on the right side, that would be x equals +1. Okay, so now we know also the graph's going to be opening up because the leading coefficient was positive. Okay, so we know which direction the graph's opening, what kind of circles we're going to have, what we're going to shade, what are the actual x-intercepts. Okay. Okay, so I'm going to come back over here, and we said that it was going to open up. My x-intercepts are at 1 and 3. So it's going to open up. I'm going to shade above. All right. So now how do we write this answer in inequality notation? So it goes -infinity less than x. You never put equal to signs with infinity. So, and then since this is a closed circle, actually, let me go back. Those should be open circles. All right. So let me make those open. Let me erase that and start it over. Okay. So 1, 3. Alright, so the blue is going to tell me that it's going to be open circles and shaded above, open circles, shaded above. Alright, and then since it's open circles, you don't need equal to signs when you write the number. And again, you always write your answer from left to right. So I did the left side first, and then and the other one's going to be from 3 less than x less than infinity. Always write your answer from left to right. The number on the left side, so -infinity is less than 1, and then over here 3 is less than infinity. It always goes from least to greatest. All right. So that's that. Move on to the next question. Number 5. Okay. Sometimes it helps to draw these. It says, while standing on a cliff, um, Anna throws a rock into the air and lets it fall to the bottom of the cliff. The height of the rock after x seconds can be modeled by h of x equals negative 16x squared plus 32x plus 192. Determine the time interval over which the height of the rock will be at least 192 feet. So, drawing a picture-wise, you throw it up into the air and it lands here. All right. Let's assume that like right here, she got it up to 192. Okay. All right. So from here above, all right, because it said at least, so that means greater than or equal to. So um, if I were to kind of sketch the picture again, you can equal 192 or greater. So it's got to be at least that. So 192 or higher. So that's the answer I'm looking for there. All right. Determine the time interval over which the height was at least 192 feet. Okay, so that's what we're trying to find. So how do we set this up in equation form? Well, it has to be at least 192 feet. So that means this over here has to be greater than that. 16x squared. So we take the equation and just put a 192 on the end and make it greater than that. Plus 192. All right. So, we set it equal to 0 because we're going to have to factor it. So I add 192 to both sides. Actually, this should have been a positive. So I'm going to subtract 192 from both sides. Zero less than. All right. So this isn't a trinomial. This is a binomial, and it looks like we can factor this using the GCF. So I'm going to take a negative 16 out, and they both have an x term, so I'm going to take out an x. And that would leave me with x minus 2 on the inside. All right. So now to find our x-intercepts, or the time intervals at which the rock is above that height, we set each factor equal to 0. So then I divide by negative 16, and I get x equals 0. And then I add 2 to both sides, and I get x equals 2. Okay, so now if we go back to that picture, it seems like she was already at 192. I guess that's where her arm was. So the moment it left her hand is at 0, and then the other number was 2 seconds. Okay, so determine the interval over which the height was at least. Okay, so we know the way we would write this answer would be so in a full complete sentence, the interval at which the rock was at least 192 feet was between 0 and 2 seconds. All right, so that's how you would write it in a complete sentence. if I asked you what the interval notation was, or the inequality notation, you would write 0 less than equal to x less than equal to 2. And then in the interval notation, equal to less than or equal to is a bracket, and a bracket over here as well. All right, so that's 3 ways you can write the answer, depending on what I'm asking for. All right. Okay, now let's look at number 6. The area of a circle A is given by the formula A equals pi r squared, where r is the radius of the circle. Solve for r. So here, we have to get r by itself. So you do this by doing opposite operations. So starting with the furthest thing away from r, which is the pi right now, we're going to, since it's attached by multiplication, we're going to do the opposite, which is division. Alright, so from there, the pi's cancel on this end, and you're left with a over pi equals r squared. Well, how do you get rid of the squared? The inverse operation of squared is square root. So take the square root of both sides. And so if you squared the square root, or if you square root a squared, it just gets rid of the squared. And then you're just left with square root of a over pi. And that's going to be your final answer. Alright. Number 7. Using the equation from number 6, with the radius of the circle being 16 inches squared, use 3.14 for pi. Round your answer to the nearest inch. Alright. On this one, we're just substituting in. We're just substituting in 16 for the area and 3.14 for pi. You just plug that in the calculator. And you end up with, and be careful here because it says round to the nearest tenth. Comes out to be 2.26, but that's not rounded to the nearest tenth. So I expect to see 2.3. That's my final answer. Alright. Let's move on to number 8. So e squared minus 4ac. And we're solving for b, so the furthest thing away from b right now is this c. But we can move the 4ac together as one whole piece by just adding it to both sides. We're left with b squared equals 13 plus 4ac. Alright, again, to get rid of the squared, take the square root of both sides. Okay, normally the square root of 4 is 2, but since it's attached with that plus, we really can't do anything with it. So we're just going to leave it there. Don't forget to put your plus minus in the front because that lets us know there's more than one answer. Alright. Alright. So here we're solving for t. So the furthest thing away from the t right now is the 1/2. What's the opposite of divided by 2? You multiply by 2. On both sides. This causes the 2's to cancel. You're left with nt squared. Now to get rid of the n, I divide. I'll have t squared equals 2m minus n. Divided by n. And just like we've done in the past, we got to take the square root of both sides to get rid of that. And we're just going to leave it like this. 2m over n. Alright, let's move on to the next problem. We are on number 10 now. Calculate the average rate of change over the given interval. Okay, with these problems, the interval's from 2 to 8. So what they want you to do when they're giving you an equation or a t-chart or a graph, they want you to know what's the y value going to be when you plug in a 2 or when you plug in an 8 for x. So the first one, let's do f of 2 equals -5 times 2 squared plus 150x times 2 again, excuse me. Alright, you can plug that all in your calculator and you'll get 2 equals 273. Alright, so you can think of this as a coordinate 273. Alright. You do the same thing for 8. Plug in 8. -5 times 8 squared messed up. This should say -7 up here. Okay, so plus 150 times 2, or times 8, excuse me. Minus, and don't forget the -7 part. Alright, put that in your calculator, and you end up with a equals 873. Alright. So I'll start on the new page here. So the first coordinate was 273. And the second one was 873. Alright, so now we're going to find, it says the average rate of change, but it's kind of like finding the slope. So the slope formula for two coordinates is y2 minus minus y1 over x2 minus x1. That's your x1. That's your y1. This is your x2 and your y2. Okay, so just plug that in the formula. 73 minus 273 over 8 minus 2 is 600 over 6, which equals 100. So the average rate of change between 2 and 8 is 100. Right? Let's go back to number 11. All right, when you're given a t-table, the information's already given to you. You just find the x values on the chart. So when x is 0, y was negative 4. When x is 4, y is 12. So again, there's your two coordinates. 12 minus negative 4. Be careful with your signs for double negatives. 1 minus 0. That's going to be 8 on the top over 4, which equals 2. So the average rate of change is 2 between those 2 points. Okay, now finding the rate of change from the interval between 1 and 3. So what they're technically asking us is x equals 1 and x equals 3. Or, like the other problems, from 1 to 3. Alright? So you come over to the graph and go to 1 on the x-axis, and you come down and find the y-axis. So went over to the 1, found the graph, it's there. Then go to the 3 and see where the graph is. Alright, so we're trying to find the slope here. So on a graph, you can use rise over run. Alright, up is positive, down is negative, left is negative, right is positive. Alright, numbers. Alright, so you gotta be careful because I made this mistake the first time. It looks like 2 blocks, so I wanted to say 2 at first, but you gotta look at the y-axis. It goes from negative 12 to negative 4. So really it's going up 8 units from 12 to 4. Now the x-axis is going by ones. So it's going left, it's going to be negative 2. So you can count each block there. So the rise was 8. The run was negative 2. And that gives me negative 4. That's the average rate of change. So be careful there. Alright, let's move on to 13. Alright, got a word problem. A seagull drops a crab 140 feet on the rock below. The function f of x equals negative 16x squared plus 144 is used to model the height of the crab, where f of x represents the number of feet x after being dropped. What is the average rate of change between 1 and 2.5 seconds after the crab is dropped? So this is like the problem earlier where we plug in 1, find a y, plug in 2.5, find a y, and find the slope between the 2 points. So first, I'm going to start a new page here. Alright, So f of 1 equals negative 16 times 1 plus 144. So that gives me 128. If you put that in the calculator. Alright, then I'm going to plug in 2.5 for x. That's going to give me 44. Okay. So my two coordinates are 128, and 2.5, 44. Alright. So 44 minus 128 over 2.5 minus 1 gives me negative 84 over 1.5, which equals negative 56 as an average rate of change. So it's negative because it's falling. It's negative because it's falling. So when you write your sentence, instead of saying negative 56, you just say between 1 and 2.5 seconds the crab is, instead of negative, you'll say falling, right? Because that means it's going down. Falling at an average rate of 56 feet per second. All right. That'll be your final answer. Okay, so looking at this problem, next one, same concept. All right. It just said a little differently when x is negative 2 and x is 0. All right. So first, plug in 0 for x. Alright. Plug that in your calculator. Or if you just did it by hand. Alright, so my first coordinate is 0, 21. And I'm going to plug in negative 2. Be careful here because there's a double negative. Negative is part of the formula, and you're plugging in a negative 2. So squeeze a 5 in there. Alright, so g of negative 2. That becomes a positive 2. So 2 minus 4 is negative 2 squared plus 5. That becomes 4 plus 5, which is 9. Okay, so that coordinate is negative 2, 9. And finding the rate of change, 9 minus 21, negative 2 minus 0, that's negative 12 over negative 2. Negative divided by negative is positive, so that's a 6. But it wants us to see which one's greater between negative 2 and 0 or 0 and 2. So that's the rate of change for 0 to negative 2. Now let's do the same thing. Well, we already know what 0 is. G of 0, so we don't have to do that work again. We said G of 0 was 21. Okay, so 0, 21 is the first coordinate we're going to use. Now we've got to do G of 2. So that is, negative is part of the formula, so I'll plug that in there. And that becomes negative 6 squared plus 5. That's 36 plus 5. And that becomes 41. Alright, so that coordinate is 2, 41. So now let's find the rate of change for this one. 2 minus 0, 20 over 2 equals 10. Alright, so which rate of change is larger, 10 or 6? Now, be careful because from, let's say that was a negative 10, or let's say the other number was a negative, let's say this is a negative 10. Well, which is bigger, 6 or negative 10? Some people would say, well, 6 because it's positive. Well, negatives don't count here. We're comparing rate of changes. Alright, this is how steep the rate of change is. So negative 10 versus a positive 10, it still has the same steepness. So always take the absolute value of the number. But in this case, they're both positive, so the rate of change between x equals 0 and x equals 2 is greater. Alright. Let's go back to the next problem. Okay, we didn't talk much about frequencies. I think we skipped that section, so for this we're just gonna skip 15 and 16. So just cross those out. Alright, now, modeling data. Decide if each table represents a linear, quadratic, or exponential function. Alright, so there's 3 ways to tell here. You look at how the y's change. Okay, let's look at this first graph. Alright, what do I do to a 4 to get to 12? I multiplied by 3. 12 times 3 give me 36, and 36 times 3 is 108, and that times 3 is 324. Okay, so if you're multiplying by the same number, it's going to be an exponential graph. Alright, now let's look at the second one. What do I have to do to get to there? Right there, I subtracted 5, subtracted 5, subtracted 5, subtracted 5. Alright, so if you add or subtract by the same number each time, then it's linear. Linear. Okay, let's look at the last one. Alright, well this one, that was add 6, add 9, add 12, add 15. Okay, those don't match. Alright, but if we can do it one more time, that's 3, 3, 3. Alright, if you do the subtraction or addition twice and then you get all the same numbers, then you can say it's quadratic. Alright, so again, if you're multiplying by the same number, it's exponential. Adding or subtracting by the same number, it's linear. And then if you do this operation twice and the second set's the same number, again, addition or subtraction, then it's quadratic. Alright, let's look at number 18, graph each set. Does each set of points model a linear, quadratic, or exponential function? Alright, so the first one, 0, 0, that's the origin, 1, 1, there, negative 1, negative 0.5, and then 2, 3. So it looks like it's coming down at a steep angle, and it looks like it's starting to flatten out there. So that's looks like an exponential function. Alright, and they can either go like that. More than likely, that's what it's gonna. I don't think I would give you any that are going downward, but that's exponential. Alright, let's look at the second one. Negative 2, 11, which is way up here. Negative 1, 5, 0, 3, and then it goes back up to 1, 5. So this one looks like a U-shaped graph, so we're going to call that quadratic. Alright, and the last one, negative 3, 8, negative 1, 6, 0, 5, 2, 3, and 3, 2. Looks like it has a constant slope, so that one's going to be linear. Alright. Moving on to the next one. Identifying the following as linear or exponential. Alright, well, if the equation has a squared in it, it's going to be quadratic. Alright, this one just has an x term, so that's linear. And this one has an x in the exponent spot, so that's going to be exponential. So that's how you can tell the difference between the equations. Alright, let's move on to part 2, which is just more practice of what part 1 was. So maybe on these you can try to see if you can do them on your own and use part 1 as a reference. Alright, let's start with number 1 and 2. Solve each quadratic inequality graphically. Write the solution, and this is important. Inequality and interval notation. Okay, so starting with number 1, Um, one x-intercept is pretty clear, -2. The other one, that's one looks like it's 1.5, but just to be sure, let's factor that. I'm going to add x to both sides. And subtract the 6. Alright. So, and again, this gives us the information that we're going to shade above. And because it's an equal to sign, we're going to have closed circles. Okay. So if I use the wheel, -6 times 2 is -12, and that's a 1 there, so 1 is going to go down here. This is a 2x squared, so we're going to put 2x here, and then we're going to come up with two numbers that multiply to get -12 but add to get -1, or +1, excuse me. So that's going to be +4 and -3. Okay. This reduces to 2/1x. That just stays -3/2x. So x equals -2, and x equals +3/2, which is the same as 1.5, which now we know exactly that that's at 1.5. Okay, so we're going to have both circles, -2 and 1.5, and we're going to shade above. Alright, so how do I write that in inequality notation? The left side goes from -infinity, less than x, less than or equal to -2. And it goes from 1.5, less than or equal to x, less than, make some room here, infinity. Alright, again, if they got solid circles, you use equal to signs with numbers. Infinities never have equal to signs. Alright, how do I write that in interval notation? Well, it's just a less than, you have a parentheses, equal to symbols have brackets. And use this union symbol. Grab some space here. And then bracket 1.5, comma, infinity, parentheses. So that's inequality on the top and interval on the bottom. Alright. Alright, number 2, we have to graph it. So we need to know a few things. Leading coefficient is positive, so it's going to open up. That tells us that we're going to shade below the x-axis, or where y equals 0. And since it doesn't have an equal to sign, we're going to have open circles. first we need to know our x-intercepts. Negative 20 times 1 is negative 20. That's a negative 1 in the middle. So that goes here. Leading coefficient is just a 1x squared. So we'll put x here. All right, the two numbers I'm going to use are negative 5 and 4. Those multiplied to get me negative 20, but when I add them, give me negative 1. Alright, so my two x-intercepts, remember to take the opposite of the sign. So that would be a positive 5 and a negative 4. Okay, so negative 4, I'm going to put an open circle, 5, open circle, it opens up. Again, we don't really care about how far the vertex goes. We just need a sketch. Alright, so we're shading below the line. So now we just have one piece that's shaded. So how do I write that in inequality notation? Well, from left to right, it goes from negative 4 less than x less than 5. Open circles do not need equal to signs. Alright, and then interval notation, numbers in the same order, you just use parentheses. Alright, so those are your two answers. Okay, let's move on to number 3. Alright. So the question says the height of the ball after the above the ground after it's thrown upwards at 40 feet per second can be modeled by the function 40t minus 16t squared, where the height h of t is given in feet and the time t is in seconds. At what time in its flight is a ball at least 16 feet off the ground? Okay, so again, we have to set up an equation. 16, it says at least, so that means it's going to be greater than or equal to that. So I could move the 16 to the right to set it equal to 0, but I want a positive t squared, so I'm going to add 16 squared or t squared to both sides. We'll move everything to the left. Alright. So what's it? 16 t squared plus 16 equal less than or equal to 40t. And I'll put a space there because I'm going to move the t to that spot. So 16 t squared minus 40 t plus 16. Okay, so that's positive, so it's going to open up. The symbol says shade below. And close circles. Alright, so I sketch this on the graph and my x-intercepts. So if I want they look like I could take out an 8. Looks like. So factor out an 8. So I'm left with 8t squared minus 5. Excuse me. It needs to be a 2. 2t squared minus 5t plus 2. This would make the wheel a little easier to work with. Alright. So again, 2 times 2, 4, negative 5 on the bottom. Leading coefficient is a 2. T. 2. T. Alright. So this reduces to negative 2 over 1t, and that just stays negative 1 over 2t. Alright, so my two t values, t is going to equal positive 2. Remember to take the opposite of it, positive 1/2. Okay, so 1, 2, 3. Alright, I'm just going to put some tick marks over here. Just kind of make it look. So earlier we said opens up, shaded below, closed circles. Okay, so we've got open circle at a half, open circle at a 2, opens up, with shade below. Alright, let's see, what were the original directions? I think they wanted us to give them both in interval and inequality. So from left to right, 1/2 less than, because it's open circles, less than 2. Writing that in interval notation, use parentheses for less than, and there you go. Those are your two solutions. Alright, now we move on to number 4, literal equations. Again, solving for x. So we're going to move the 5y first, because that's the furthest thing, then the 2, negative 2, and then the exponent. So first, getting rid of the y term, you subtract that on both sides. We're left with 2x squared, negative 2x squared equals negative 9 minus 5y. Then I get rid of the negative 2 by dividing everything by negative 2 less x squared equals or you could write it like this, depending on how they give you the solution on the test. Okay, if that's the case, they don't like having negatives on the bottom, so it would be negative 9. So just change all the signs, so that way it looks like that. Alright, so to take the square root of both sides, so I'll just feel like on a test they usually leave it like this. So x equals square root of -9. And you can't take the square root of -9, even if it was positive. They don't like you taking anything out when it's connected with pluses and minuses, so that would be your solution. Next one, we're solving for v, so we got to get rid of the r, the m, then the squared. So first get rid of the r by multiplying, because that's the opposite of division. Times r times r. I'm just going to write up r equals m. R's over here cancel. Alright, now I've got to get rid of the m. So I'm going to divide by m. I'm left with v squared equals v times r over m, just like we've been doing. To get rid of the squared, I gotta take the square root of both sides. So my final answer, v equals the square root of f times r over m. Alright. Okay, looking at number 6, it says, given the function g of x, f of x, and h of x shown below, the correct list of functions listed from greatest to least by average rate of change over the interval 0 to 3. So we're going to use 0 and 3 for all three functions. Alright, so first, and then see what is their average rate of change from greatest to least. Going to put them in that order. First, let's start with g of x. G of 0. Alright, all of that ends up being 0. Then we're going to go to plug in 3. So 3 equals 3 squared minus 2 times 3, which gives us 9 minus 6, that's 3. Alright, so my two coordinates are 0, 0, and 3, 3. So we got to find the average rate of change there. So 3 minus 0 over 3 minus 0 equals 3 over 3, which equals 1. So average rate of change for that particular function is 1 from the interval 0 to 3. So we're going to put a 1 there underneath that function. Now we're going to figure out the rate of change from 0 to 3 for that particular function. So 7 minus 1 over 3 minus 0 equals 6 over 3, which equals 2. Alright. And then the last one, 0 is my x value. So where's the graph? It's there. Then I go over to 3, find the point on the graph that correlates with that. Alright, now I'm going to find the slope of that line, which is rise over run. So the run is 3. The rise is 2 to 9 is 7. So rise over run as a mixed fraction, that would be 2 1/3. Okay, so we had to order these from greatest to least. The first one would be h of x, then f of x with a rate of change of 2, and then last would be g of x. Again, be careful because negatives don't matter here. So the answer to that one is the letter D. Moving on to number 7, thrown in the air as a height of this function, feet after t seconds, find the average rate of change. So just like we've been doing in the past, plug in 0 for t, alright, so that's going to equal 3. So 0, 3 is the first coordinate, and then let's squeeze this in here. Alright, so h of 2 equals, plug all that in your calculator, that would give you 39, so 239. Alright, so 39 minus 3, 2 minus 0, 36, 2 equals 18. So that's the average rate of change. So I guess since it's a word problem, we write a sentence. The average rate of change between 0 and 2 seconds is 18 feet per second. Okay. Alright, again in part 2, the sequence section, we can skip that because we didn't cover it. Alright, going to the next problems. True or false? Read each of the following statements. If the statement is true, write the word true. If the statement is false, write the word false. A quadratic function always exceeds a linear function. And the answer to that is, for instance, let's draw an example where it's not true. Say we had a quadratic function. Maybe at first it exceeds it, but eventually if it was down, if it was turned, if the parabola was facing up, then no, it wouldn't. But here's an example of when it would. So all you need is one example that's false to say false. Eventually, an exponential function would always exceed both a linear and quadratic function. We'll say yes. So it's going like that. It just grows faster than a linear equation. This is true. Go to the next slide. Okay, decide if each table in the graph represents a linear, quadratic, or exponential. So like we did before, it multiplies its exponential, add or subtracts by the same number. It's linear. If you add or subtract the y values twice, and then the second set is the same number, then it's quadratic. Alright, so this first one, looks like we're adding 3 each time. So that would be linear. This one, looks like we're multiplying by 2 each time. 10 times 2, 20. 20 times 2, 40. So this is going to be exponential. Alright, and then the last one. Okay, let's look at number 14. From here to here, that's negative 0.5. From here to here, it's a negative 1.5. Go from here to here, negative 2.5. And here to here is a negative 3.5. Alright, those aren't the same, but let's try it one more time. That's 1, 1, 1. If you subtract 1 each time. So now, because all these are the same, we're going to say quadratic. Alright. Looking at the equations, again, this has a x squared term, so that makes it quadratic. This has a linear term of x, so that's linear. And this has an x in the exponent spot, so it's exponential. Okay, now we're going to base our decision of which of the 3 they may be based on the way they look. Number 18 has a constant rate of change, so that's going to be linear. Second one is a parabola, that's quadratic. And the last one approaches 0 but never crosses it, and then the rate of change changes drastically in the positive direction. That's exponential. Alright, number 21. The table shows the estimate number of deer living in the forest over a 5-year period. Are the data best represented by a linear, exponential, or quadratic model? Write the equation to the model. Well, we have multiple choice here, so okay. So first, let's see if it's linear. So that's going to be minus 121 Um, 16, there. It's going to be 12. And the last set, 10. Alright, so it's not linear because those aren't the same. So the next set would be 5, 4, 2. Those aren't the same. So it's not linear, it's not exponential. So that can eliminate that. I'm sorry. It's not linear or not quadratic. So I can eliminate these equations. The only one that's left is exponential. Now, how did they get 0.7? Well, when you're trying to figure out what you multiply by, 32, just work backwards. 32 divided by 42 gives you, it's like 0.76. 42 divided by 54 was like 0.77. And so they're all about 0.77 each time. So that's the rate of change. So that would make sense on how they got that number. Alright. And that's the last problem.